Hello and welcome back to Cracking the Cryptic for another attempted Sudoku solve today. So this is a puzzle by Dying Flutchman, who has appeared on the channel multiple times and sets incredible Sudokus, often on the hard side. Let that be a warning to me, to you, to us. Intriguing. We'll have a look at this in a minute, and it's got a very odd rule set that I know I'm going to have trouble with. Simple but odd. Simple but unusual, let's put it that way. Don't forget that on Patreon there's still the equal sum line Sudoku, the May reward that you can enter until the 20th. There is the Quinlux build your own hunt going on. That's harder. The build your own is very approachable. The Quinlux is more at the level that I expect this Dying Flutchman to be. It might not, but that's what I expect. And of course, all our apps are available. They have puzzles that are vary between, well, they tend to be quite approachable to a little bit more difficult. That's about what I would say. It's not really hard level. And they're all available, lots of them updating now, which is great. We hope within a week or two to have all our past apps fully updated to the 100 puzzles each. And then we can move on to some more content, which will be brilliant. We're looking forward to that. What else is going on? Well, a crossword video up this week on Patreon. Loads going on, as always, on Discord. And just check out Sven's SUDOKU PAD. There's loads of links in the description field. The first one is to this puzzle, Floating Sandwiches by Dying Flutchman. Normal Sudoku rules apply. Black dots join digits with a 1:2 ratio, so that could be 2 and 4, for instance. White dots join consecutive digits, so that could be 4 and 5. Not all dots are shown. There are 18 crust cells in the grid, 2 in each row and column. Crust cells can have any value and can differ in each row and column. Now that's what's going to confuse me. Hang on, let me explain the last bit of the rule. An outside clue gives the sum of the digits between the crust cells in that row or column. So for instance, if in this column we had crust cells there and non-crust cells there, these 3 digits would add up to 14. These could be anything according to the rules, but there are 2 of them in every row and column. Whether or not we get a clue. Okay. Now, why that's going to confuse me is because I am so used to 1 and 9 being the values of the crust in normal sandwich Sudoku that I see a 35 row and I immediately go, oh, well, there's a 1 and 9 there and these are the filling. The other thing that's going to confuse me is it specifically says there are 2 crust cells in each row and column, and it doesn't say there are 2 in each box. And if I solve a sandwich Sudoku, I'm often looking for the crust cells, and I'm assuming there are 2 in each box, and this is not necessarily the case here. So if Dying Flutchman has been kind, there will be 2 in each box, but I suspect, since it doesn't say that in the rules, there probably aren't. But speculation, schmeculation. Let's have a go at the puzzle, see how it pans out, stop worrying about it before we actually get into it, and let's get cracking. Okay, so 35 is not the place to start because that row is very unlikely to have its crust cells adding up to 10. I think we start in this 40 row. Yes. Okay, the way to look at this is to use a little known secret that I'm going to share with you now. Every row, column, and box of a Sudoku puzzle adds up to 45 every time because of the 1 to 9, that is what it adds up to. Now, if we subtract the 40 that makes up the sandwich in this row from 45, we get the number 5. And that number 5 must make up the 2 crusts and any outies, any numbers that are outside the sandwich and the crusts. So if you had 2 crusts here, this cell would be an outie. Now, can 3 cells add up to 5 and in a single row? The answer is no, because the minimum value of 3 cells is 6. 1, 2, and 3. Education in triangular numbers today. So I think we know that the crusts are on the outside of this row that they add up to 5, because that's the difference between 45 and 40, and that therefore these green cells add up to 40 and fulfill the rule. So these are either a 1-4 pair or a 2-3 pair. And that must be right. And that's my deductions for now. I'm not sure what else we can deduce. Okay, something else we can normally deduce in regular sandwich Sudoku, and I'm going to have to work out how it applies here. In a 35 row, well, I would know that all of those were crust. But even in a 25 row, I would know that all of those were sandwich. Even in a 25 row, I'd know that this one was. Because if this was crust, well, you can put a crust there or there, but you're never going to get more than a 3-cell sandwich. This still applies here. 3 cells can't add up to 25, whatever their value is. So the number is smaller in a sandwich Sudoku. I think as soon as you get 22 clue or more, you can do that. In this, 25 is just enough. That is the number at which we know this must be in the sandwich. 35, definitely. 30, definitely. 25 is the number. So, okay. Well, these are having an effect on the 14 column. That's great. Okay, we've got a start, actually. Thank you, Dying Flutchman. So what I wonder next is whether I can make this cell green. Now you can tell that in this column, the 14 sum would then be in these 5 cells and maybe more. But that's impossible because here we go with the triangular numbers again. The minimum number, the minimum total of 5 digits is 1, 2, 3, 4, 5 is 15. So that 14 being 1 less than that means this cannot be green and must be a red crust. These 2 cells must be green because wherever the 5 sum occurs, it could be 1 or 2 cells long, but these can't be crusts in the row. And in fact, these can't be crusts in the row either because the 5 sum can't be more than 2 cells. So this is useful. Now, I don't know whether the 14 sandwich goes up or down, whether it's 2 or 3 cells. So I can't do much else in column 5. If I could allow myself to believe that this box would only have 2 crusts in it, which is not a rule, then I would happily deduce that the... no, actually, I know that they don't. Right, sorry. 35 is an interesting number because the minimum number of cells to make 35 is 5. This is not a triangular number. I don't know what the opposite of a triangular number, but if you count down from 9, 8, 7, 6, 5, that's 5 cells. So the sandwich in this row is at least 5 cells, and therefore it must contain the middle 3. That's safe enough. So in fact, we now know there is only 1 crust in the middle box, which might help me understand that. Now, I don't know. It could be those 5, it could be those 5, or it could be 6 or 7 cells of sandwich here. I just don't know. So I'm not going to speculate about that anymore. I'm going to look at these 7 clues. Now, the first thing I started to wonder is if these can be in the sandwich. The minimum distance for a 7 sandwich. Now, in a sandwich Sudoku, it would only be 2 cells. But in a floating sandwiches Sudoku, I suppose this could be 1, 2, 4. And that would work fine with the black dot. That could be 1, 2, 4 as long as 1 and 2 were on the white dot. So these could be in the sandwich, or they could not be in the sandwich, in which case the sandwich will be a single 7 either there or there, and there or there, which would form an X-wing if we could do them both. But how do we know? I don't know how we know. Oh, hang on, I do know how we know. Or do I? Sorry, okay, here's something we do know. Yes. Okay, what I just said is quite important. Where can the 7 sandwich be in each of these columns? And it is either the crusts are there and there, or the crusts are there and there, or the crusts are there and there. Now, in all of those cases, Oh, no, bother. Sorry, I was getting hung up on the rule again. I'm just wondering, does one of these two cells always have to be a crust? Does one of these two cells always have to be a crust? I'm not actually sure. If neither of those was a crust. Ah, no, the one situation in which neither of these could be a crust, in which they could both be green, is that the two crusts were there and there and there and there. Now that's fine for the box, but the sandwich digit would be a 7 in both of those cells, which is too many in the box and the row. So actually, no, one of these is red. I don't know which one, not both of them, because that wouldn't allow the 30-something. In fact, whichever one is red has its other sandwich. If that one's red, then it's these 4 cells. 9876 is 4 cells and makes 30, and that will be what the sandwich is made up of in this row, because it's either a crust there and a crust there, or a crust there and a crust there. So in any event, these are green. And one of these outside ones is a crust, and is the second crust in its column. Ah, which has now meant that this 35 clue cannot span across. There must be an outie in it. At least one, there could be 2. Okay, that's, I don't know how to pencil mark that thought. Only one of these could have a 3-cell 7 sandwich in the middle. This is a 9, 8, 7 or 6 because one of these groups of cells there or there is 9, 8, 7, 6 to make the sandwich. This really is all about identifying the sandwiches and the crusts, I think, to start with. Then there's probably a second phase of puzzle of doing some digits. Right, this can't be green. Oh no, hang on, that's not true. I was going to say, okay, this can't be a 2-cell sandwich sum, because how would you do 5 in 2 cells? That would have to be either 2, 3 or 1, 4, and you can't put both of those on a black dot. You can't put 1, 4 on a white dot, but you can put 2, 3 on a white dot. Oh, you can't put 5 on a black dot. That's the point. So the sandwich cell in this row is not 1 cell. It is 2, and it can't be there. That is right. Yes, it's got to be 2 cells here, and there are 2, 3 pair. Yes, we're away. That is red. These are green. Ah, this can't be 1, 2, 2, 4, or 3, 6. That's a 4, 8 pair. This is 4 or 6. This is 3, 5, 7 or 9. Oh, this now can't be 1, 2, 4 in the middle. See, you didn't think it was worth pencil marking this cell, but that's what's told me that. But this still could be 1, 2, 4. Bother. What next? This 35? Oh no, this 25. Now, if that's 3 cells, that's red. I'm just wondering, is it now true that one of these has to be red? Yes, it's always been true for exactly the same reason. If those were both green, we'd have reds all the way here, and both of these would be 7s, and that's impossible. So again, one of these is red, and yeah, 25 acts the same as 30. Even though the 30 is the maximum 4-cell sum, 25 is the minimum sum at which we know we need 4 cells, because 987 doesn't cut it. So it's exactly the same position as in row 7. In this row, row 3, we are going to have red in one of those two, the other red at one end or the other, and therefore the cells in between green. Ah, okay, now I am going to colour these, because this is a kind of X-wing. Oh, hang on, has this gone wrong now? No, I don't know. No, one of these highlighted cells in row 3 is red. One of them in row 7 is red. Together with the 2 in row 6 in columns 1 and 9, that's all the red cells in columns 1 and 9. And everything else in columns 1 and 9 is green. That is like a weird virtual coloured X-wing, which is a beast I never expected to meet. Right, so they're all green. Now look at row 4. That's beautiful. These middle cells must be the sandwich, 98765. Those are the crusts. Now I've got a box with 3 crusts in, which doesn't feel right. But this can't be a 3. This is 98765. I'm going to pencil mark it. These are 40, so these add up to 5. Wow, okay, now none of these other numbers are big enough to be wonderful. 19 has to be 3 cells. Ah, so this is now green, because 3 cells on the left would be there, 3 cells on the right would be there. That's in the sandwich. Oh, but we've got the 2 red cells in column 2, so they're green, and now the sandwich must include that cell as well. Wow, okay. Yes, because 5 was offset. That's why we got the 2 reds there. Okay. So now those 2 can't add up to 7, and those 3 can't add up to 7. Sorry, they can't. Sorry, that can't be the single 7 because this isn't a crust. So that's not a crust because that can't be 7. So this is just a green cell. That has gone red. That goes red. This goes green. This must go green now because we've got the 2 reds. That goes red. That goes red. And that goes green. And there we go. Right, that's a 9876 quad. These add up to 25. I can't pencil mark those. Oh, this is such a clever puzzle. Right, the 7 here is there, and it is a number 7. Here, this now is green, so that's not a 1, 2, 4 trip. In fact, since that became 5, 6, 7, 8, 9, of course. So we get another red and a green 7. 7s are the first numbers in the grid, it seems. Those can't be 7s. 7 is on the dot, so 9 isn't. So one of these 2 is a 9. What else does that give us? That's given us quite a bit. Right, the 19 sum. That's green, that's red, yes. That's given us the 2 reds in column 8. Oh, it's lovely, isn't it? Still don't know about this 14. It could be those 2, those 2, those 3. Oh, I've got a 15 sum up here. Oh, gosh, I haven't even used that. Right, that's done. The 7 has made that green. That's green because we've got the 2 reds. And, well, I've got the 14 still to decide, but the rest of these whites are in rows and columns without clues, so I don't know how I do them at the moment. So I might have to stop here and do the numbers and then come back to the colours later. Fair enough. Now, what can we do? I mean, we know nothing, apart from this one. I don't think we know anything about the identities of the red cells. And they don't really matter in this puzzle. That's so strange. Hang on. In this row, they are 1, 2, 3, and 4. Yeah. So then look, there's a 1, 2, 3, 4 quad. How does that help? If at all. Don't think it does. Bother. It's got to be a 7 somewhere here. 1 hasn't been placed in this box. Wow, none of this stuff with the dots is unwinding at all, as far as I can see. Okay, the 15 at the top, right. That's a 6-9 pair. I'm not sure that's going to get anything done either. Ooh, it might affect. Okay, the 14 sum in this column is definitely 2 cells long. because red is either there or there. No, I was going to say that means this can't be 7, but that's not true. It does mean, no, I don't know where that 2 sum adding to 14 is, irritatingly. Oh, bother. Oh yeah, hang on, look, column, sorry if you've been shouting this, column 7 needs 2 red cells and we've got 2 whites left, so I can finish that off. Oh, I can't, still can't do these. Oh, that didn't do any good to me at all. Okay. Now, these add up to 19. We can't have a 9 or a 7 there, and only one of 8, 6. So the most they can add up to is 12. 8 and 4. That's right, isn't it? If that was... No, that's not quite right. If that was 8, 6... No, that can't be. They've got to have a 9. That could be 9, 6. That's the least it can be. 7 there. Then 8, 4 here is 12. And that would be a 7. And that doesn't work. If that was 9... Oh, there is a 7 on that dot. So this has to add up to more than 12 now. No, to less than 12. 11 or 10, and this must be 8 or 9. This is either, there's a 9, it can 8, 2, 8, 3, 6, 4, 6, 5. Have I got my maths right? It doesn't feel right. Let me think about this again, sorry. If that is minimum, its minimum is 9, 6 because it has the 9 in. Then the maximum this can be is 8, 5, is 13. Then that would be a 6. Now that is possible. It can't be a 7, so that is 6, 8 or 9. Okay, I thought my maths was further out than that. That's really weird to do a check and find, although you were wrong, you weren't wrong in the way you thought you were wrong and why you were doing the check. That's what just happened to me there. You're fascinated by that, I know. So, I don't know if this is where... Okay, this sum doesn't have a 7 in it because there's a 7 there and a 7 there. Actually, that means there's a 7 in one of those cells. Can't be on the black dot. It could be 9, 8, 2, 9, 6, 4... 8, 6, 5. Those are the 3 possibilities, which aren't very helpful. Don't have a 3 in. 9, 8, 2, 9, 6, 4, or 8, 6, 5. They're using up lots of high numbers between those and these cells, but I don't think that gives me anything I can write in here. These ones are all from 1, 2, 3, 4, 5. Let's put that in just for the sake of doing something. I don't know. Oh, if that was a 2, 3 pair in the 5 crusts, that would make a 2, 3 pair in box 4, and that would have to be 1, 4. Ah, that doesn't work. Look, if that's a 2, 3 pair, let me just flash these cells. We'd have 2 3s in all these positions. Those 2, which are from 1, 2, 3, 4, would have to be 1, 4. That would mean those 2 would be 2, 3. And now we've got too many 2 3s in box 6. How bizarre. I don't know what that's doing as a deduction. But it means this is not a 2, 3 pair. That's a 1, 4 pair. So this is not a 4. Oh, that is brilliant. Right, 6, 3, 2. Come on, do some work, deduction. I bet it does nothing. it does this, 9, 6 pair. This now can't be 6 or 9. This can't be 6. 6 must be in one of those two cells. That can still be 9, 8 or 5, 4. That's going to form a virtual pair. That is either 9, 8 or 5, 4. That's going to form a virtual pair with that one, and we're going to have used up 8 and 5 in the box. So that now becomes 7 or 9. 5, 8, 3, 6. So the 2 is down here and up here and not here, which was obvious from the fact that we had this as soon as we got that 2. Now this can't be a 1 anymore. Is that all I can do? Yeah. Oh, this adds up to 25. What's the max here? 8, 5. So the minimum for these two is 12. No, that's not interesting. Okay. That's a 1, 3, 4 triple, of course, now. Oh, is that all I've done? I just thought that was a big breakthrough. This can't be a 3. That can be a 3. That could still be a 4. Okay, bother. Right, there is a 3 in those because of the 1, 3, 4 triple. So there is a 3 down here, and there's not a 3 up here, and we've got a 1, 2, 4 triple as well. And that sees that cell. Wow, 8 there, 4 there, 5 there, 8 there. These can't be 5 or 8. Gosh, this is brilliant. 7, 2, 3, 4, 8. So no, I still don't know that 6 is in one of those. 1, 2, 4. That got me the 8. So that's not an 8. Now, there are any sandwich clues. Now. Yes. No. That could be the sandwich. 5, 9. This can't be a 6. Oh my goodness, this can't be the 14 sandwich now, because that would have to be a 5 or 6 with that 8 or 9. That's not possible. Wow, so that's green. This is red. This is red. This is green. We've finished colouring. Hurrah. The 14 is up here, so this can't be a 7. That's a 9 with a 5. That's now a 6, 7 pair. We've done all the down clues, effectively. We've done that across one. We haven't done this at all. We've done that, we've done that, we've done that, we've done that. So it's just the 19 and the 25 clue left to do. I'm going to colour them a little, just so I remember that we still have to establish those. But the rest is Sudoku? Oh, I suppose, and Kropki. Strange puzzle. Right, we've got a 2 in one of those, we've got a 7 in one of these, and a 1 somewhere. Oh, that's become an 8. Aha! So this is a 6, 7 pair, and that's a 9. Now I've got a 6, 7 pair in the column, so that's not 6, and it's not 8. So thanks to the work I did earlier, that's a 9. These two add up to 10. They must be 6 and 4, and that set is done. Excellent. Right. What has that given me? Apart from further headaches. Oh, come on. It must have done something. There's a 6 there and a 6 there. Any of those could be a 6. Actually, that one can't, because that would be a 5 on a black dot. So one of those two is a 6. 3, 6, 5 is how that would work there if that was a 6. Right, we've got a 5 in this 20-some. Right, the other 3 add up to 20, and now they can't be 8, 7, 5, so they must have a 9 in. The 9 must be in one of those cells. Then we need 2 more that add up to 11, and they can't be 8, 3, because that cell couldn't sustain an 8 or a 3. So it's 9, 7, 4. So this is now a 9, 7 pair. And that's where 4 goes. And now I have finished using all the floating sandwich clues. and I can't get anything else out of the thematic content of the puzzle. I'm just going to have to solve it as a Kropke Sudoku from here. How extraordinary. This can't be 4 or 5. That hasn't changed what this can be at all. That's 1 or 2. So one of these down here is a 5. These are from 1, 2, 3. So that can't be 1, 2 or 2, 3. So it doesn't have a 1, 3 or a 7 in it. 9 has to be over here somewhere as well. Okay, what I was going to observe is there's either a 5 or a 9 on this white dot because it needs an odd digit. And now we've placed those candidates. This can't be 1, 2 or 2, 3. Oh, but it could be 3, 4. Okay, so I'm talking absolute tripe. A habit of mine. No, it can't be 3, 4 actually, because there's got to be a 4 in those cells, so there isn't a 4 in those. So it is either 5, 6 or 8, 9 on this dot. So that is 6 or 8. How bizarre. So this is 3 or 4 and it cannot be 4. Right. 3, 6, 5. Exactly what I suggested it might be earlier. Turned out to be true. 1, 2, 4 there. We get a 5 there. That's 9. These two are now a 7, 8 pair. These are from 1, 2, 5. Hooey, what a puzzle. That can't be 3. So the 3 in the row goes here. That makes this a 2 in the red cell above on the white dot. Not because it's a red cell, because it's a white dot. And we've got a 1, 4 pair. 2, 7, 9, 4, 5. So 1, 3, 8, 6 to go up here. That one can't be a 6 and that one can't be an 8 or a 6 because there's a 6, 7 pair here. Now, does that mean, so there is a 6 in those two. So this black dot is not 3, 6. I don't know that. I don't think I can whittle down what that is yet. Although it's the last set of dots that I need to study. Interesting. Okay, we get a 3 up here. We get, oh, we've placed 2 in box 7. This isn't one of those puzzles where you think you can finish every instance of a digit in the grid when you've found 1 or 2. Not at all. Right, 7 and 7. So one of these two's a 7. It can't be on the black dot. Oh, but that's not forming a useful X-wing or anything like it. One of those two's an 8. Oh, that can't be 2. Right, so this is now 4. Oh, that's a use. Okay, that's a white dot. I didn't realise I hadn't finished because I wasn't noticing it. So that's a 4 by Sudoku. This is a 1. That's fixing 4 and 1 down here. Now there's going to be a 1 in one of those two. This is a 3. One of those is a 3. I've known that for a long time. Should have used it. That's not a 4, so this is a 1, 2 pair. Now I can place 1 in the central box and 2 and 7, and the central box is finished. That is 2 or 3. That is 2 or 3. That's not very helpful. 6, 7, 2, 4. One of those is 3. The 9 has fixed the 7, 9 pair up there. Now we get a 9 here. That is 7 or 8. We can place 6 in the first column. Oh, it's not 7 or 8. We've got a 7 in the box. Bingo. Finished box 7. That's a 6. That's a 7. That deals with the 6, 7 pair there. This is a naked 5. We've got a 3, 4 pair up here. This must be a 1, 5 pair. This is 7 and 8. We can write them in. This is 3 and 9. Oh, it feels like we might be drawing to a beautiful conclusion here. That's become a 1. 2, 4, 5 in the column. Let's have a look at this now. Right, there's no 6 on it according to these 6s. There's no 1 on it according to that. So it's either 2, 4 or 4, 8, and it's definitely got a 4 on it, which doesn't resolve anything. Yes, okay, if there's definitely a 4 in those cells, and there's 1 there, this becomes a 4. That is a bit useful. We get a 2, 5 pair up here. We know where 7 goes now. Let's remove that. These can't have a 1. They can't have a 2 because of the 2, 5 pair we've just put in. So now they can't have an 8. And in fact, we know which way around they go once they're 6, 3. That fixes 5, 6. That fixes 5 in the bottom row. That's a 9, and the white dot finishes us off up there, which surely is going to do the business elsewhere. That's an 8. That's now a 1, so we get 3, 2, 1. We can finish everything down at the bottom, well, in all the bottom 6 rows, I think. Get a 1 and an 8 there. That looks like it's worked. This becomes 2 and 3. That fixes our last 2 pairs, and that is the solution to floating sandwiches. And I think that is a genius puzzle. That is so clever throughout. That's really interesting. So few clues. I mean, I suppose these give a bit, but the way that central box worked to get into it was absolutely gorgeous with the 2, 3 and the 4, 8. Lovely puzzle. I don't know if you had to do that deduction with the 2s and 3s here. That was really interesting. I loved that. That was mega entertaining throughout. Thank you for watching, as always. Thank you for following us on the channel. Do hit like, do hit subscribe, watch us all day long, or just dip in every now and then. We really don't mind. Lovely to see you. Hope to see you again soon on the channel. Bye for now.